Hi, hope this short video on Nuclide Symbols helps you understand how to answer some of the questions for the isotope worksheet and just to understand the structure of the nucleus as well as the number of electrons as well. So a nuclide symbol is simply a way of representing a particular isotope or ion of an element. So that is, atoms come in lots of different forms, even for the same element. So the same element is really just determined by the number of protons. So if the number of protons remains constant, we have a particular element, but if the number of neutrons and or electrons vary, we have different forms of that particular element. We generally talk about versions of the atom with different numbers of neutrons as being isotopes and different numbers of electrons as being ions, but of course they could have both, which tends to get a little confusing. So the easiest way to talk about that in general is through a visual method, which is simply to write down a version that shows us how many protons, neutrons, and electrons the particular isotope or ion has. So, for example, we could be talking about something like copper. Copper, you might find a symbol, Cu is the general symbol for copper. So you might find a version of copper that looks like this. That would be a nuclide symbol for copper. So what can we glean from this information? Well, the main thing, honestly, is that we've got three pieces of data here, and those three pieces of data help us either directly or with one small calculation learn about the three different subatomic particles: protons, neutrons, and electrons. So this lower left number represents the atomic number. And the atomic number sometimes is abbreviated with capital Z, and it simply represents the number of protons. So this particular copper, as with all copper atoms, has 29 protons. If they don't have 29 protons, they're not copper. This number in the upper left is called the mass number. It sometimes is abbreviated with the letter X, capital X, and it represents the number of protons plus the number of neutrons. Now please note that is not the number that appears on the periodic table for most elements. The number that appears on the periodic table for most elements is an average of all the different isotopes for that particular element. This is just one particular isotope, so therefore it has a nice whole number, but when you get a bunch of different versions of elements all added together and weighted for which ones are more prevalent, you get a decimal, a rounded version of the average mass of that particular element. So for this particular atom with 57 as its mass number, well, 57, if we rearrange things minus the number of protons, minus 29, would tell us that this has 28 neutrons. So we have 57 total minus 29 protons equals 28 neutrons. So we have 28 neutrons, we have 29 protons. We know about two of the three subatomic particles. And this tidbit of data here in the upper right tells us the third bit, that is the charge. And the math here is a little roundabout, but the number of electrons equals the atomic number minus the charge. So I guess we could say that the charge equals the atomic number minus the number of electrons. So the number of electrons in this case would be 29 minus the 2 for the charge, which would be 27 electrons. And it should make sense that we have fewer electrons than protons because the entire version of this element, this atom, this ion, has a positive charge, meaning there should be more protons than electrons. So we'd end up here with 28 neutrons, 29 protons, and 27 electrons. All right, I hope this helps you with your homework and for general knowledge, and I will talk to you later. Bye-bye.